Good day everyone, this is Sir Fred and welcome to another video lesson tutorial.
For our lesson for today, I'm going to discuss finding measures of position using the linear interpolation method. Let us take a look at the following objectives. Illustrate the measures of position for ungrouped data, namely quartiles, deciles, and percentiles. Number 2, compute for quartiles, deciles, and percentiles of ungrouped data using the linear interpolation method. And number 3, interpret measures of position for ungrouped data. At this moment, I'm going to discuss to you the third method of finding measures of position for ungrouped data, and that is the linear interpolation method. Let us define first what is interpolation. When we say interpolation, it is the process of finding a value between 2 points on a line or curve. For quartile, decile, and percentile, points between two numbers needs to be interpolated in order to get the exact value. Let us take a look at the following formulas that we are going to use under the linear interpolation method. For quartiles, deciles, and percentiles. As what you can see, class, the formula for quartiles, deciles, and percentiles for linear interpolation method are just the same as with the Mendenhall and Sinsich method that I discussed to you in the previous video lesson. For quartile, decile, and percentile, the value of k stands for the position of the data or the index, and n stands for the number of position. Let us take a look at the following steps in finding quartile, decile, and percentile rank. So first, we need to arrange the data in ascending order. Number 2, find the rank using the formula for quartiles, deciles, and percentiles. And finally, locate the position of the score in the distribution. There are some cases that we need to remember in identifying the position in the distribution. If the quotient that we obtain after we use the formula is a whole number, directly locate the position of the quartile, decile, and percentile in a set of data. But if the quotient obtained has a decimal value, we are going to proceed for interpolation. So class, we have certain steps that we need to follow if we are going to interpolate the value that we get in a set of data. Here are the certain steps that we need to follow under linear interpolation. So letter A, find the difference between the two values wherein Q sub k, D sub k, and P sub k is located. Letter B, multiply difference with the decimal obtained. And letter C, add the product in a smaller value in step A. So class, we are going to apply these formulas in some of the examples that will be presented on the succeeding slides. So take note class that the examples that is shown on your screen are the same set of examples that I used in the first two methods that I discussed. So take note class that the values that we will get from the different measures of position may differ from the method that we used in solving. So in this first example that we have, considering these are the set of the scores in the mathematics 10, and we are asked to identify for the lower and the upper quartile, the first step is for us to arrange the data in ascending order. Applying the formula for the quartile, so we have k is 1, n is 11, getting the quotient of 1 times the quantity 11 plus 1 all over 4, that is equal to 3. Since the value that we get is a whole number, so what are we going to do is to directly locate the position of that in a set of data by counting the value of the lower quartile is equal to 9. By interpretation, 25% of the scores are less than or equal to 9, while 75% of the scores are greater than or equal to 9. For the upper quartile, using the same set of data, applying the values in our formula, k is equal to 3 times the quantity 11 plus 1 all over 4. Simplifying it results to 9. Since it's a whole number, we directly locate the position of that in our set of data by counting the third quartile is the value of the ninth position, and that is equal to 14. By interpretation, 75% of the scores are less than or equal to 14, while 25% of the scores are greater than or equal to 14. In our second example, we're going to identify for the lower and upper quartile in a given set of data. After we have arranged them in ascending order and substitute the values in our formula, for the lower quartile, we have 1 times the quantity 12 plus 1 all over 4, that is equal to 13 over 4, getting its quotient results to 3.25. So class, observe that the value that we get here is different from the first example that we have. Here we have a decimal value, and according to the rule that we have read a while ago, if the value or quotient that we get as a decimal, we are going to proceed in interpolation. So of course, we are going to locate where does 3.25 be found, and by counting, that is between the third and the fourth position. So after we have identified the location of this value that we get, so let's proceed in the steps for interpolation. So in our first step, we are going to get the difference of the values of the two positions. So for the fourth position, we have 12. For our third position, we have 10. So the difference of 12 minus 10 results to 2. In our second step, we are going to multiply the difference that we get in our first step by the decimal that we obtained a while ago. So that is 2 times 0.25, that results to 0.5. And on our final step, we are going to add the product that we obtained in step B to the smaller value in step A. The smaller value here that we get its difference a while ago is 10. So we have 10 plus the product that we get in step B, that is 0.5, results to 10.5. So therefore, class, the exact value of our first quartile by using the linear interpolation method, that is 10.5. For our third quartile or upper quartile, substituting the values in our formula, so we have 3 times the quantity 12 plus 1 all over 4, that results to 9.75. Since just like in our first quartile, the value that we get has a decimal value, so let's proceed to interpolation. So locate first the value 9.75 in our set of data. Where does 9.75 located, class? That is between 9 and 10th position. So since we already have identified the location of the data, so we are going to get the difference of the values of the 9 and 10th positions. So that is 18 minus 17, that is equal to 1. The difference that we get will be multiplied from the value that we obtained. Okay, that is equal to 1 times 0.75, that is equal to 0.75. And finally, we are going to add the product in the smaller value in step A, that is 17 plus 0.75, that is equal to 17.75. So therefore, the exact value of the third quartile is 17.75. Consider the following scores of the 12 students in our third example. So we are asked to identify for the value of the first, the fourth, and the ninth decile. So class, the first step is for us to arrange the data in ascending order and apply or substitute the values in our formula. So for our first decile, that is 1 times the quantity 12 plus 1 all over 10. So that is equal to 13 over 10. So 13 over 10 results to 1.3. So class, we again have a decimal value here. So therefore, we are going to interpolate it. So we need to identify the location. Where does 1.3 located? That is between the first and the second position. So since we have identified the location, get the difference of the values of the two positions, that is 10 for the second and 9 for the first, that results to 1. In our second step, we are going to multiply the difference with the decimal obtained, that is 0.3, and finally adding the product to the smaller value in step A results to 9.3. So therefore, class, the value of D sub 1 is equal to 9.3. For our D sub 4, we are going to apply and substitute the value. So we have 4 times the quantity 12 plus 1 all over 10 results to 5.2. So just like D sub 1, we're going to interpolate this, class. It's because we have a decimal number. So first, locate the position. Where does 5.2 located? That is between 5th and the 6th position. In our first step in interpolation, getting the difference of the 5th and the 6th position, we have 15 minus 4 results to 1. Multiplying the difference with the decimal obtained, that is 1 times 0.2 results to 0.2, and adding the smaller value in step A with the product that we obtained in step B results to 14.2. So therefore, class, the exact value of the fourth decile is equal to 14.2. And finally, class, for our ninth decile, so we have 9 times the quantity 12 plus 1 all over 10 results to 11.7. So since we have a decimal number here, so let's proceed to interpolation. So locate where does 11.7 situated, that is between 11 and the 12th position. So get the difference of the values of the two positions. We have 20 for the 12th and 19 for 11th. So that is equal to 1. So the difference will be multiplied in the decimal that we obtained a while ago. That is 1 times 0.7 results to the same value. And adding it to the smaller value in step A, that is 19 plus 0.7, that is equal to 19.7. So therefore, class, the exact value of the ninth decile is equal to 19.7. And finally, class, for our final example, in applying the rules of linear interpolation, considering these are the scores of the 12 students, and we are asked to identify for the 40th and the 65th percentile. So by arranging the data in ascending order and applying the formula for the percentile, that is k times the quantity n plus 1 all over 100, so let's begin identifying the value of the 40th percentile. So that is equal to 40 times the quantity 12 plus 1 all over 100, resulting to 520 all over 100, getting its quotient, that is equal to 5.2. Since we have a decimal number, so let's proceed to interpolation. 5.2 is located between the 5th and the 6th position. Getting the value of the 6th and the 5th position by counting and getting its difference results to 15 minus 14 equals 1. The difference will be multiplied by the decimal obtained, that is 1 times 0.2, that is equal to the same value, and adding it with a smaller value in step A, that is equal to 14.2. So therefore, class, the 40th percentile is equal to 14.2. And finally, for the 65th percentile, we have 65 times the quantity 12 plus 1 all over 100 results to 845 all over 100. Getting its quotient results to 8.45. Since we have a decimal value, we'll be proceeding to interpolation. The location of 8.45 is between 8 and the 9th position. So we need to identify the value of the 8 and the 9th position. So we have 18 for the 9th and 16 for the 8th. Getting its difference results to 2. The difference will be multiplied to the decimal that we obtained, that is 0.45 times 2, that is equal to 0.9. And finally, adding it to the smaller value in step A, that is 16 plus 0.9 results to 16.9. So therefore, class, the exact value of the 65th percentile is equal to 16.9. To summarize the things that we have learned for today in finding measures of position using the linear interpolation method, here are the steps that we need to remember in finding for the quartile, decile, and percentile rank. First, we are going to arrange the data in ascending order. Second, find the rank using the formula for quartile, decile, as well as with percentile. And finally, we're going to locate the position of the score in the distribution. If the quotient obtained is a whole number, directly locate the position of the quartile, decile, and percentile in a set of data. But if the quotient obtained has a decimal value, proceed for the interpolation. Letter A, find the difference between the two values where in Q sub k, D sub k, and P sub k is located. Letter B, multiply the difference with the decimal obtained. And finally, add the product in a smaller value in the first step. And by that, thanks for watching and see you on our next video lesson. Don't forget to click the subscription box and notification bell to stay updated.